Section 1.3, example 19, using the fundamental theorem of calculus with two variable limits of integration. So let f of x equal the integral from x up to 2x t cubed dt. So find f prime. Okay. So this part feels correct as long as we're looking at x being greater than 2x, or we're looking at like positive numbers, maybe negative numbers, I don't know. But we could simplify this as looking at it from two. So we could kind of turn this into two different integrals, the sum of two different integrals. Remember when we integrate, we could look at the sum from here, all of this, breaking it up here. So looking at this sum over here and adding this sum over here. No, it looks kind of weird, but we could look at those separately. So what we're going to do is separate those two variables into two like bite-sized variables. So let's get to separating. So f of x is equal to, we said, from x to 2x t cubed dt. We could separate those two. We'll say from x up to 0 t cubed, and we could add from 0 to 2x t cubed. This is dt. I'm not so crazy about this one right here. So what I really want to do is switch these two and then just put a negative out in front of it. So we are able to do that just looking at the like a different orientation. And the right one goes from 0 to 2x, so that one's fine. All right, so now we have this new set of integrals that we could actually differentiate to see what those values are on the inside. So f of x, let's just rewrite it. And as we have been doing, we're going to take the derivative with respect to x on both sides. So derivative with respect to x of f of x, we could just state that as f prime of x. It's still the derivative, just a different notation. Here we're integrating into x. So we have negative t cubed. All right. So negative t cubed there. Plus, all right, so this one's going to be a little weird, but here we still have that t cubed. But remember, we have chain rule. Over here, the derivative of x is just 1. Over here, the derivative of 2x is 2. So we have that. And then with respect to x here, we could just simplify those two there. What did I do? Oh, I see what I did. All right, so we're looking at 2x cubed, and this isn't t. This should be x. 2x cubed times the derivative of that 2 times the derivative of 2x. There we go. So now we have negative x cubed plus 8, 16, 16x cubed gives us that 15x cubed. And there we go, f prime of x. Wrong one. There we go. All right, so one more time. I'm so sorry about that. So what we're doing is we're inputting that x into the function itself. So here, that's where we just ended up with that x cubed right here. The negative traveled down from there because we like switched the orientation to make it manageable. Over here, what we're doing is we're getting that x or that output and inputting it in here. So the whole thing ended up being that 2x cubed. So the whole thing ended up being that 2x cubed. just like we did in the previous problem, we're looking at the derivative of 2x, which is just 2, and we're multiplying that in over here. So we have 2 cubed, which gives us 8. So we have 8 times 2 gives us that 16. And then just simplifying it one more time right there, we end up with 15. And there we go. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.